Hey guys, it's your favorite math teacher here, Mr. Jenkins, with the first lesson of Chapter 5. So just before we get started, Chapter 5 will kind of round out the semester. It'll be the last unit we cover. So the Chapter 5 test and then your potential test retake would be kind of the two things you have left to really, what I like to call move the needle as far as your overall grade is concerned. So buckle down and finish strong. All right, so our first lesson is about polynomial functions. If you remember, last chapter was all about quadratic functions, some function containing an x squared term, right? So now we're doing higher degree terms. That is what Chapter 5 is about. Our learning target for this lesson, I can classify and graph polynomials and describe their ending behavior. All right, so let's get in. A lot of this is vocabulary and stuff like that. So a real number, a variable, or a product of a real number and one or more variables with whole number exponents is called a monomial. So that just means one term, right? If you have multiple variables joined together by multiplication, that's considered to be one term. In a one variable monomial, the power of the exponent tells us the degree of, the polynomial. A monomial, or the sum of monomials, is called a polynomial. Poly means many. In a one variable monomial, the highest degree or exponent is the, let's change that word, that should be polynomial. The highest degree is the degree of the polynomial. Sorry, this one up here should be monomial. So the highest degree term tells us the degree of polynomial. So an example that you should be familiar with, if we think about standard form of a quadratic, ax squared plus bx plus c. Our highest degree term is right here because it's got the exponent 2, right? So that defines this polynomial as a quadratic polynomial. All right, so then there's some stuff clipped from the textbook. Basically, it talks about the standard form. So you just know your exponents go in descending order of, degree. So one example I just put up on the board, second degree, first degree, 0 degree, all right, or constant term. Same thing with a cubic polynomial. It goes third, second, first, and then 0. Your constant's always last. All right, so we're going to start out with some classifying. Okay, so on your notes, for those of you who like to print them out, this is not exactly user-friendly because this is on the bottom of the front page, and then your examples are on the back. So not real user-friendly, but this chart will help you with some of your Math Excel problems. Our directions say write each polynomial in standard form and then basically classify it by degree and number of terms. 2 ways to classify it. All right, so we're going to start with standard form. So I have a 4th degree term, a 3rd degree term, and a 1st degree term. So we just put those in descending order. So 5x to the 4 goes first, plus 3x to the 3 goes next, and minus x would have to go last. So now we're going to classify it. So by degree, it's 4th degree, so that's called quartic. And how many terms? 3, so that's called a trinomial. So overall, this is a quartic trinomial. Right, let's do maybe one more, and then I'm going to leave a bunch of those for you guys. Let's just skip ahead and do this one. So looking at C, We have negative x to the 5 plus 2x to the 2. And then I wanted to do this one because these two you would not write as two separate terms, so you always want to combine like terms. So you wouldn't put plus 10 and plus 3, you put plus 13. So this would be a 5th degree or quintic. And guys, to be honest with you, I don't like memorize these terms. Obviously, quint means 5, but I would have to refer to this chart on some of these things. And then polynomial of 4 terms. So in other words, once you get past a I don't know why binomials in there twice, but once you get past 3 terms, there is no special word for how many terms there are. All right, so I'm leaving B, D, E, and F for you. I'll probably ask you about one of those on the Ed Puzzle video. Okay, so now we are going to look at the end behavior. So remember, end behavior is one of your, or it's part of your learning target. So this is going to be important kind of stuff here. So the degree of a polynomial function affects the shape of the graph, the turning points, and the end behavior. The places where the graph changes direction are called the turning points. So that could be singular or plural. And a parabola, which I just happen to have one right there, that has one turning point, right? So the vertex happens to be the turning point on a parabola. The directions of the graph to the far left and to the far right are called the end behaviors, or end behavior. Okay, so for example, on this graph, it says it goes up and up. This one down and down. This one starts down, ends up. This one starts up, ends down. Okay, and it gives you a table right here that you can use. But to me, what I find to be more helpful is I kind of think of these 4 graphs right here. If this helps you, this is what helps me to remember this. Okay, so I think of a normal parabola. So that would just be like y equals x squared. So that's a positive lead coefficient and an even degree, right? And that would be up and up. So if we put a -1 in front of that, right, that flips it. So that would be like y equals -x squared. So that would be a negative lead coefficient and an even degree. Okay, so I think of my parabolas for the even ones. And then you're not as familiar with cubic functions yet, but you will get to be. Like you've seen them before, but haven't talked a lot about them. But your normal, like y equals x to the 3, kind of looks like a snake. So that'd be positive and odd, starts down, ends up, or up, sorry, down and up. And then we flip it if we put a negative out front. That'd be y equals -x cubed. So that's how I remember all of these, and I'll try to show you how I use that. So what we want to do is say, what is the end behavior? Okay, so looking at y equals 4x to the 3 minus 8x. Now, obviously, you can type that into Desmos and look around on the graph, but you should be able to answer these a little bit easier. So a is +4. And the degree is 3. So that's odd. So we are looking for what's the end behaviors for a positive A, and an odd degree. Positive and odd. So that'd be just like that graph. Positive A, odd degree. So it should be down and up. Down and up. Okay. So hopefully that makes sense. Let's do maybe one or two more. So looking at B, A is negative 2. Okay, doesn't matter the 2, just matters the negative, and the degree is 2. So that's even. So we have negative and even. That's like this one. So that'd be down and down. All right, and then think about C real quick. We have A is -1, and the degree is even. So negative A, even power. That'd be like this one right here. So that would also be down and down. So hopefully you get that. And like I say, if you don't know, you can always plug it into your graphing calculator to Desmos and just look at the graph of it. All right, so we are going to finish with, a couple of these graphs. All right, so looking at just this first one, how would we graph it? So you want to include kind of your keys when you're graphing these things. All right, so you want to include any turning points. You want to include any increasing intervals and any decreasing intervals. I'll tell you what I mean on that in just a second. Okay, so just kind of summarizing what we just did, I should be able to look at this real quick and see that it's positive and an odd degree. So that should be down and up. That should be a down, starts down, finishes up. All right, so let's go ahead and use our T-chart here. See, they just plugged it in for us. We see the graph. It does start down, finish up, right? And then we'll just fit whatever we can fit on the graph. I believe this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 10. So we'll plot -1, -6. We couldn't fit -2, -29. We'll plot 0, -1. We'll plot 1, -2. We can plot 2, 3. And that's probably going to be the last one, yeah. So that'll give us some good, what I call guide points. And then we kind of look at, make sure we get all those changes in direction on there. So if we kind of trace here, best we can. All right, that's what you want to look at. So how many turning points do we have? We have, there's a turning point and there's a turning point. So there are 2 total turning points. There and there. How many increasing intervals? So increasing means as we read a book, as we move from left to right, it is increasing, right? So it's increasing from here, from -infinity to here to our turning point. So that's 1. This is an increasing interval. And then we have another increasing interval. Anytime it looks like kind of a positive slope. So 2 increasing intervals, and then you have your 1 decreasing. It decreases from there to there. Okay, so 1 decreasing. All right, so that's basically how we summarize one of those graphs. So I'll do one more where I have to use my graphing calculator. All right, so this one they give to you a little bit weird. We would want to write that in standard form to kind of be able to really think about it. So it's y equals x cubed, negative x cubed, negative x cubed plus 3x. All right, so in this case, this is a negative a and an odd degree. So that should be the opposite of what we just did, right? So instead of down and up, it should be up and down, right? That's what we should expect to see. So up and down. And then we have some blanks to fill in. All right, so to get my points, let's go ahead and type all that in. And just to be clear, you could type it in just like you saw it there. It wouldn't matter. I just prefer standard form. So negative x to the 3. So you're going to use the caret key. If you didn't see that, let me type that one more time. Clear all that out. So that was negative x and then to the 3. So you can use that button as a shortcut for squared. There is no really that button for x to the 3, so we want to just use the caret key. And then plus 3 times x. And I know most of us are visual, so we'll look at it and see if we at least got the first part right. And you see that it is up there, finishes down, so up and down. All right, so let's go ahead and confirm that. We can tell that just by looking. All right, so up and down are turning points. Now I'm going to go to my table, right? I want to get these exactly right. So on these, I got to be a little more exact. So I'm going to go to my table, all right? And I'm going to get anything I can fit on a 10 by 10. It looks like from -2 to, let's see, +2. That's kind of the part of the table I'm looking at. So it looks like -2, and again, I'm just looking at my table here. -2 maps to 2, so -2, 2. It says that -1 maps to -2, so that's right there. 0 maps to 0. 1 maps to 2. And 2 maps to -2. So obviously, if all you had was those 5 points, that just looks like a die, right? So you kind of need the picture to go along with it, right? Or else it's like, I don't know really how any of that works. Okay, so I would combine your guide points with your picture, and now it's a little bit more clear. Okay, so then we just kind of trace through our guide points. Okay, then we have a pretty good picture. So how many turning points do we have? Looks like that's a turning point, and that's a turning point. Okay, they call those, another word for those is local, kind of max and min. 2 turning points. And that makes sense because the last one had 2 as well, right? So if it's third degree, it's going to have 2 turning points and a total of 3 different intervals, right? So how many increasing intervals do we have? Increasing is as we move from left to right, it gets the function increases, y gets bigger, right? So it only increases from there to there. So we have 1 increasing interval. And if we had to name that interval, then you could use, like interval notation or whatever, but it increases from -1 to +1. They're not asking us to do that, but if you were asked to do that, that's kind of your thought, and then 2 decreasing. So I just highlighted those. And if you remember the last problem, that's kind of the reverse of what we had on the last one where it was flipped. It had 2 increasing, 1 decreasing. All right, so anyways, that's that lesson. Lots of kind of general, knowledge stuff, not a whole lot of math going on in there. So I would encourage you to use those charts when you're working through the homework because, a lot of this stuff is not necessarily intuitive, but you kind of have to learn it as you go through your practice. That's all I got. Have a nice day.